In conclusion, I'd like to use some little examples to cap up the lessons on parameters, and I hope you enjoyed the videos. Let's go. I have a linear equation. Y is equal to mx. M can be 1, 2, 3 to infinity. M also can be less than 1. M can also be of a negative value. But let's take the case of M is equal to 1. You can see the graph is a straight line passing through the origin. Simple. From 0 to positive infinity and from 0 to negative infinity. Now, let's take a case where M is 2. What happens? The outcome of the graph is changed. You can see the graph becomes narrow. What I mean narrow means narrow with respect to the y-axis. It comes closer to the y-axis. It moves. It still passes through the origin. It moves towards the y-axis because M is equal to 2. M is a parameter. M also represents the slope of the graph. That's one. Let's take another case. Y is equal to mx squared. In this case, is a quadratic equation. M cannot be 0 anyway. M cannot be 0. So let's M be equal to 1. M is equal to 1. If M is equal to 1, then the equation is y is equal to x squared. So this is a graph in blue. It passes through the origin, number 1. It faces up, number 2. Then it goes from negative infinity to positive infinity. Yes, that's the characteristics of that graph. Now, let's make M greater than 1, for example, 2. If you make it 2, what happens to the graph? Number 1, it makes a graph narrow. In other words, it makes it skinny. You can see the one in black. That's a graph of y is equal to 2x squared. It makes it skinny. If M is greater than 1, the graph is narrow. If M is less than 1, the graph is wide. If M is less than 0, that is negative, the graph will flip and open downwards. So you see the effect of the parameter 2 on the graph. So the parameter also, I think I mentioned it in the explanation, determines the end behavior of the graph. What do we mean by end behavior? End behavior can be explained by saying, as x starts from 0 and gets too large and approaches positive infinity, the graph will also approach positive infinity in this direction. As x gets too small, in other words, it gets too large in the negative direction. Here, it goes too large and goes to the negative infinity. The graph will also approach positive infinity. That is because the parameter is positive, making the graph open up. Now, if that parameter was negative, in that case, the graph will open downwards. What will happen with the end behavior? As x gets too large towards positive infinity, the graph will also approach negative infinity. As x gets too large in the negative infinity, up to negative infinity, the graph will also approach negative infinity. So see the the difference, how it affects the end behavior of the. This applies to all the graphs, whether it is linear, a quadratic, cubic, or any form of graph. The parameter affects the end behavior. Now, you know that parameters affect the outcome of equations, polynomials, functions, and rest of them. So, and you are going to be coming across them in many and different ways. In fact, parameters serve as constants in formulas because they are used as constants in some formulas. But we shall come across them as we make progress. See you in the next video.